Hello and welcome everyone to Infinity Learn by Sri Chaitanya. I'm Ravindram and today I'm going to discuss the solution to the physics paper of JEE Main 1st February morning shift. Okay, so let's start with this. So first question in that paper was, with rise in temperature, the Young's modulus of elasticity. So generally we think that it remains unchanged. No, but what happens as the temperature increases, the stiffness of the material always decreases. So Young's modulus of elasticity decreases. This will be the correct answer here. Option B. Is that okay? So as you go on increasing the temperature, so Young's modulus of elasticity decreases, as we can also say that stiffness decreases. Clear? Okay, let's move on to the next question. If r is the radius of earth and the acceleration due to gravity on the surface of earth is g, that is pi r square, okay, pi square, then the length of the second pendulum at a height h equals to 2r from the surface of earth will be. So what is the second pendulum? So let's say time period is 2 pi root over L by g, right? Now timing we need to keep same, right? Timing we need to keep same. So length will be L dash and g will be g upon 1 plus h by r whole square. Yes or no? Is this clear? So what will be L dash? So we will just equate them. Okay, g and g will get cancelled. Simply you will say, sir, root L is equals to root L dash into 1 plus h by r whole square. Now what is this h by r? H is how much? 2r. So 1 plus 2, that is 3, 9. Okay, are you understanding? Oh sorry, not square, that is just 3. Okay, so now you put the values. So from here L dash will be L by 9. Okay, so the answer will be 1 by 9 meter. Now you will say, sir, by 1, because it's a seconds pendulum. Seconds pendulum mein you will say, sir, time period is 2 seconds generally. So we will say, sir, 2 is equals to 2 pi into root over L by g, that is pi square. So from here L comes out to be 1 meter and hence L dash, which is L by 9, comes out to be 1 by 9 meter, and hence second option is correct. Clear everyone? So let's move ahead and discuss the next question. So this is actually a bonus question, right? All these 4 options are wrong, they do not match, first of all. Okay, so let's move on and solve the question. What is the exact answer? Now in this question they have asked, in the given circuit, if the power rating of Zener diode is 10 milliwatts, power rating of Zener diode is 10 milliwatts. So power rating of Zener diode means I in the Zener diode into V across the Zener diode, right? So what is V given? 5, and this is given what? 10 milliwatts. So it is 10 milliwatts IZ, and what is VZ? VZ is given 5 volts. So we will say that maximum current that can go through the Zener diode will be 2 milliampere. Yes or no? Maximum current that can go through it is 2 milliamperes. And minimum current that can go through is 0, right? So let's consider this condition. Usually when single option is given and not the range is given, they are not asking the range, they are asking single option, then we will consider that the Zener diode is under working condition and the current is passing through it. That means 2 milliampere, that is the maximum possible current that can go right now as per the conditions given in the question. Okay, right? Now let's talk about this. So here if it is 5 volts, so this will also be 5 volts, right? This is 1 kilo ohms. So what is the current here? So IL will be how much? It will be 5 by 1000 ampere. So IL will come out to be 5 milliampere. Is that okay? So this is 5 milliampere. So how much is this current? 7 milliampere. Do you understand? The current will be 7 milliampere, and how much voltage here? This is overall 8 volts. This is what? 5 volts. So what is left here? 3 volts. Right? So finally you will say that IS into RS is equal to VS. So RS will be equal to VS upon IS. So it will be 3 upon 7 milliampere, right? So it will be kilo ohms. So it will be 3 by 7 kilo ohms, which does not match with any of the options, and hence it was under the bonus category. Okay students, Let's move on here. The reading in the ideal voltmeter V. So here in this question, if you see, there is no load resistance, it is 0. So if there is no load resistance, so what happens? Every single battery, whatever the terminal voltage across every battery will be 0 only, right? Because there is no load resistance in this case. So answer will be 0, C option. Clear? If there would have been any load resistance, like here somewhat they would have given some load resistance RL as suppose 10 ohms. Then we need to solve, find the current and then use this concept. Terminal voltage across every cell will be EMF minus IR. In this case, this terminal voltage will be 0. Why? As EMF is equals to IR only. Right? That's why terminal voltage is coming out to be 0, because there is no load resistance. Now let's come to this. Two identical capacitors have same capacitance. One of them is charged to potential V and the other is charged to potential 2V. The negative ends of both are connected together. When the positive ends are joined together, the decrease in potential. So there is simple formula for the loss: half C1 C2 upon C1 plus C2 into V1 minus V2 whole square. V1 minus V2 whole square if the positive sides are connected together and the negative sides are connected together. But if they're connected in opposite polarities, that means positive plate is connected with the negative plate, then make it plus. That's all. Okay. So half into identical means C square, that is C square by 2C into 2V minus V whole square. Right. So it will be CV square by 4. How much? So what they are asking? The decrease in energy of the system or the loss. So loss will be this, half CV square. Oh, not so, this, not this, A. CV square by 4. Is that okay? CV square by 4 will be the right answer. 2 moles of monatomic gas is mixed. Okay. So what is the formula for CV of the mixture? CV of the mixture is R by 2 into N1 F1 plus N2 F2 upon N1 plus N2, right? So CV of the mixture will be R by 2 into N1 is how much? 2 moles. F1 is how much? 3. Why? Because it is monoatomic. So for monoatomic gas, degree of freedom is 3. For diatomic gas, degree of freedom is 5. How many moles? 6 moles. Okay. Upon 2 plus 6 is how much? 8, right? 2 moles and 6 moles. 2 plus 6 is 8. Now let's solve it. 2 3s are 6. 6 5s are 30. 36 upon 8. So CV of the mixture will be 36 R by 16. Right? 36 R by 16. Now tell me. So it will be how much? 4 9s are 4 4s are. So 9 R by 4. Which option is correct? First option is correct. 9 R by 4. Clear? Simple formula based question it was. Very simple to solve. Very easy to solve. Okay. So this question they are saying. Okay. The answer is coming out to be T is equals to M omega square L. Right? So here omega is root over T by ML. So T is how much? T is 400. Right? So 400 upon 0.5 into 0.5 under root becomes 20 upon 0.5, which is nothing but 40 radian per second. Look at it. Okay? Simple formula, answer will be B. So this is the formula that we will apply in this case. Now, what is the value of IRMS? IRMS is ERMS upon XC. Okay, because there is only pure capacitor, right? A parallel plate capacitor has this, it is connected to this supply. Okay, omega is given. Okay, so conduction current and displacement current, whatever. So IRMS is given how much? 230. It is 1 by omega C, right? So 1 upon omega C. Omega is how much? 300. C is how much? 200 picofarad, right? 10 to the power minus 12. So 10 to the power 12, like this. Okay. So if we solve it, Finally, you will say that, sir, after solving, it is coming out to be 13.8 microampere. 13.8 microampere. So listen to me. Conduction current and the displacement current, they are always equal, okay, in a capacitor. So option D will be correct. Very simple question. Just put the values and get your answer. Now, here what is the work done? For an polytropic process, work done is P1 V1 minus P2 V2 upon A minus 1. That's all. What is A? A is 3 by 2. 3 by 2 minus 1 is half. So work done is 2 times P1 V1 minus P2 V2. Now there is a slight glitch here. They have just asked work done. That's all. But they have not asked work done by the gas or work done on the gas. So either this can be true or this can be true. Because they have asked work done by the gas, then option A. A will be correct if they ask work done by the gas. This will be correct if they ask work done on the gas by the surrounding. Is that okay? This is important. A galvanometer has a resistance. A galvanometer, suppose this is a load resistance across which we need to measure. So this is galvanometer coil. This is shunt resistance. Now this is a voltmeter. So it has resistance Rg, it has resistance Rs, and this will be Ig, right? So a reading of voltmeter will be, it will be Ig into Rg plus Rs. Okay, now just put the values. What is galvanometer resistance? 50. Measure up to 100 volts. 100. Current is 5 milliampere. Resistance is how much? 50 plus Rs. So we have to figure out Rs from here. So it will be very simple. 5 ones are 5, 20s are. So it will be 20,000. 20,000 minus 50, how much? 19,950. So option C will be correct. You will say, sir, Rs will be 20,000 minus 50. So 19,950 ohms. Clear, everybody? This will be the correct answer for this question. Now the de Broglie wavelength of a proton and alpha particle are the ratio of the velocity. See, we know that momentum is equals to h by lambda, right? So it is mv is equals to h by lambda. So v is equals to h by m lambda, right? So velocity of what? The ratio of the velocity of proton to alpha particle. So proton to alpha particle will be mass of alpha particle, lambda of alpha particle upon mass of proton into lambda of proton, right? Mass of alpha particle is 4m. Mass of proton is m. What about the wavelength? So de Broglie wavelength of a proton is lambda, and it is, I guess, 2 lambda, right? So after solving, the answer comes out to be 8:1. 8:1, which option is correct? Fourth option. Okay, guys. Here we are saying 11 VSD is equals to 10 MSD. So generally we say N VSD must be equal to N minus 1 MSD. So least count is always 1 MSD upon this N. Okay? So 1 MSD is 5 units, N is 11. So answer is 5 by 11. D option. Cool. Now in series LCR circuit, to keep the resonance frequency unchanged, what is a resonance frequency? It is 1 by 2 pi root over LC. So in this, if you increase the capacitor 4 times, so obviously if you say that C becomes 4C, so to keep the frequency same, L must be L by 4, right? So answer will be, it should become L by 4. So it should reduce by 3L by 4. Reduced by 3L by 4. Understood? So that the frequency remains same. Now this is very simple. Just put the values. You will say, what is the formula? Rho L by pi R square. Sorry, I think I should pick up a separate R for this. Pi R square. Okay. So what do they need? Resistivity is how much? capital R into R square by L. Okay, pi, we can remove pi. Okay, like this. So you will say, sir, delta rho by rho into 100% will be delta R by R plus 2 times delta small r by small r plus delta L by L into 100 will be percentage, right? So just put the values. What is delta R? So you will say from here delta R by R will be 0.05 by 0.35. Okay, and this will be delta R by capital R will be 10 by 100. Okay, and delta L by L will be 0.2 by 15, right? So you know these values. Now what you need to do is put these values. Don't forget this 2 here. Why? Because it's in power. Multiply by 100%. So answer comes out to be this. Now they are very bad because they are very close. They have given very close values. So this question was absolutely nonsense because the data was also not so good. Plus the values that were given in the options were also very close, right? At least not D, but at least B and C were very close, quite close. Okay, so sometimes you might tend to make mistake in this type of question. So be very alert while solving, mathematically proficient, then only you can solve this and get your exact right answer. Now the dimensional formula of angular impulse. अब angular impulse क्या होता है? MVR. So it is kg meter per second into meter. So it is m1 L2 t minus 1. m1 L2 t minus 1, option D. Very simple. A simple pendulum of length 1 meter has a wooden bob. A bullet is coming like this. It hits and gets embedded in it, right? So this is capital M, this is a small m, this is a small u, and after collision what will happen? Once the bullet is inside it, it goes with V and will go to a certain height h, right? So they have asked us to find out this h. I guess that is what the question is, right? So here the bullet is coming, hits it and gets embedded in it, and then this whole system goes with a common velocity v and goes to a height h. That's all they have asked in this question. So what we will do, the height to which the bob rises before swinging back is, okay. So first of all, we'll use momentum conservation and say mu is equals to small m plus capital M into v. Now small m is very small, right? 10 to the power minus 2 into u is how much? 2 into 10 to the power 2, right? Is equals to obviously almost 1 into v. So v comes out to be 2 meter per second. Now h is how much? H is always, the formula is v square by 2g. So 2 into 2 by 20, right? So it will be how much? 0.2. Option B. Clear? So height will be 0.2 meter. Done, everybody? So very simple formulae. You must remember these formulae. When an object is given a velocity v, to what height it goes? It is v square by 2g. Now a particle moving in a circle of radius r with uniform speed. Acha, circle of radius r with uniform speed v, then v is equals to 2 pi r upon time period. If this particle is projected with the same speed at an angle theta to the horizontal, maximum height attained by it is equal to 4r. The angle of projection theta is, so what is the formula for maximum height? If you throw an object with v, it goes like this. So maximum height is v square sine square theta by 2g, right? So we will say height is equals to 4r is equals to v square sine square theta by 2g. So now from here you solve and you will get the right answer. Obviously the answer will be in terms of sine only, not cos. So these two are gone, right? What is the difference here? Okay, so let's quickly check the difference. So it will be how much? This 4 and this 2 will get cancelled first of all. So your answer will definitely contain only 2 in the numerator, nothing else. 2 in the numerator and pi in the denominator. So 2 in the numerator, that means option A is correct without even solving. Okay? Now here we have to find out the acceleration. So this is A, right? Now overall, if we talk about, this is T, this is T, and this is kinetic friction, right? Now number one, what is kinetic friction? It will be mu mg, right? Mass is 20 kg, mu is 0.04, so 20 into 10, so it will be how much? 8 Newton, correct? Now what is mg for the lower block? That is 60 Newton. So we will say it like this: 60 minus T is equals to 6A, and T minus 8 is equals to 20A. Understood? So 52 is equals to 26A. So A is equals to 2 meter per second square. Drawing the FPD and writing the equations, you will get your answer C. Now the minimum energy required by hydrogen atom in ground state, okay, to emit radiations in Balmer series is nearly, the minimum energy required by hydrogen atom in ground state to emit radiation in Balmer series is nearly, ground state to Balmer series, so N will be 3, minimum energy transition they want. So delta E will be what? 13.6, right? 1 by 1 square minus 1 by 3 square electron volts. So solving this, you will get approximately 12.1 electron volts, which is option D. Cool. It will be 8 by 9 times this. 8 by 9 times 13.6 is 12.1. A monochromatic light of wavelength. Okay, so they have asked linear width of central maxima, that's all. So linear width of central maxima is 2 lambda d by A. Okay? So it will be 2 into 6000 into 10 to the power minus 10 into 20 into 10 to the power minus 2 upon 0.01 into 10 to the power minus 3. Right? Now 1, 2, 3, 4, 5, 6, 7, 8, 9 will be like this. Okay? So overall it will be 24 into 10 to the power minus 3, which will be 24 millimeter. This will be the correct answer. Got it? A regular polygon of 6 sides. Okay. A regular polygon of 6 sides hai? Haan. So that means they are talking about a hexagon. Okay. So what is this? This will be 30 degrees. This will be 30 degrees. Current will be I like this. We have to find out magnetic field here. Okay. And this distance will be R. And generally R is L sine 60. That is root 3 L by 2. Is that okay? Right? And we will find out magnetic field due to one element and then multiplied by 6 to get the overall magnetic field at the center. This length is L. It's an equilateral triangle. Na? So this angle is 60 degrees. That's why I said that this distance will be L sine 60 degrees. So that will be root 3 L by 2. Anyways, let's come back. So what is the formula of magnetic field? You will say, sir, mu naught by 4 pi, mu naught I by 4 pi R into sine theta 1 plus sine theta 2 multiplied by n sides. So number of sides is 6. So mu naught by 4 pi into, what is length? Length is given 4 pi meter by 6. 4 pi meter is total sides, total 6 sides. So one side will be 4 pi by 6. So it will be 4 pi by 6 into root 3 by 2 into I. I is how much? 4 pi root 3. Okay? Into half plus half. Now we can solve it from here. You'll say, sir, this 4 pi, this 4 pi, this root 3, this root 3, 6 6 is 36, 2 is 72 into 4 mu naught by 4 pi is 10 to the power minus 7. Right? So I guess x comes out to be 72 in this numerical. Cool. This is a wonderful question. It will take little time to explain, but focus here. What they have given is, what they have given, I will write it on this page, then I will take an extra slide so that I can explain you the solution on that slide. Okay. So first of all, the concept is somewhat like this. This is given y-axis, this is given x-axis, and let's say that a loop is kept like this, rectangular loop. Okay. So this is 0, 0 and this is minus 12, 0, and obviously this height is 5 centimeter. Magnetic field is like this, outwards, right? So this magnetic field is changing with distance, like gradient. In this direction it is changing, along with it is also changing with time. So this magnetic field, this is a very good question in this paper. Overall in this paper only this question is lovely. Okay, this question is very good. So magnetic field is changing with space as well as it is changing with time. So we'll consider both the factors, find out the overall EMF induced in this particular rectangular coil, and then once we know the overall EMF induced, then we can clearly say the power will be overall induced EMF upon R, right? So just we need to figure out what is this. R is also given, a resistance is 6 milliohms, that's nothing. Okay. So the main information is how to find out the EMF induced in this particular coil, given the conditions are like this. Okay. So let's begin with it. Now look here carefully. This is y-axis, this is x-axis, this is minus x, this is the loop. So let's name the loop A, B, C and D. Now this loop is moving here with a velocity v. Let's say this is given 5 centimeter per second and this length L is 5 centimeter given like this. Okay, this distance is 12 centimeter given like this. Here the x coordinate is 0, here the x coordinate is minus 12 centimeter. Okay, these informations are given, plus given the magnetic field is outwards like this. So I hope this much is clear to all of you in this question. So this much data is absolutely clear. Okay, now let's solve it. So let's find out. See, the EMF induced in the BC and DA because of the movement will be what? Tell me. It will be 0, right? Because velocity and length vector are perpendicular here. So because of the movement, B and C will not have any induced EMF. So the only induced EMF will be in CD and BA, right? So let's talk about the rod. So let's say the magnetic field at x is equals to 0. So at x is equals to 0, let's say magnetic field is B naught, right? So what is EMF induced here? V cross B, so downwards. So we will say EAB, right? That is EA minus EB. This will be B naught VL, right? Cool. This is point number 1. Now what is the magnetic field here? So what else, what information they have given? They have given that dB by dx is minus 10 to the power minus 3 Tesla per centimeter. Okay, Tesla per centimeter. Cool. I'll correct it once, right? Minus. So we will say, sir, B is equals to, so dB integration, right? So dB integration from B naught to B, this is minus 10 to the power minus 3 dx integration from 0 to x, right? So it will be like this, B minus B naught is equals to minus 10 to the power minus 3 times x. So B is equals to B naught minus x times 10 to the power minus 3. Is that understood? So this is how we can find out magnetic field. So from now this information we will find out magnetic field at this point. Okay. So let's talk about the third point. What x is equals to minus 12. So what is magnetic field over there? It will be B naught minus 12 into 10 to the power minus 3. So B will be B naught minus plus 0.012 Tesla, right? So once you know this, now here also, what is the direction of velocity here? Magnetic field is outside. So V cross B, that means the lower portion will have higher potential. So DC will be how much? B naught plus 0.012 into VL. Is that understood, everybody? Just have a look and let me know if there is any doubt in this. Simply we'll solve it like this. Now let's move on to the next part of the question, because we have just found out the space variation but not have figured out the time variation yet. Okay, now let's talk about the overall EMF. So it looks somewhat like this. Do you understand? So this EMF is let's say E1, this EMF let's say is E2. So E1 is EDC, which is B naught plus 0.012 into VL, right? And E2 is EAB, which is B naught VL. So E1 minus E2 will be the effective induced EMF, that will be 0.012 VL. Is that okay? And if you're looking for the values, it will be 12 into 10 to the power minus 3 into 5 into 10 to the power minus 2 into again 5 into 10 to the power minus 2. So 5 5s are 25. 25 into 12 will be 300 into 10 to the power minus 7, right? 300 into 10 to the power minus 7, which will, I guess, become how much? 3 into 10 to the power minus 5 volts. So this is the EMF induced just because of space variation of magnetic field, right? And the movement of this. Now next you look here, this is the coil, okay, this is length, this is breadth, right? And magnetic field is like this, which is reducing with time in the outward direction. So if it is reducing, it is in the outward direction and reducing, so EMF will be induced in such a way so as to support it. So current should be like this. So if current should be like this, that means there should be an EMF like this in this coil, let's say E dash. So I guess they both are supporting each other, because here also the effective EMF is like this, here also the effective current will be like this, right, because of this. So E dash will be what? A dB by dt, right? A dB by dt this time. So A is LB, so 5 into 12 into, let me correct it, it will be 5 into 10 to the power minus 2 into 12 into 10 to the power minus 2 into dB by dt is 10 to the power minus 3 Tesla per second, right? So 5 12s are 60 into 10 to the power minus 2 into 10 to the power minus 5. So it will be 0.6 into 10 to the power minus 5, right? So overall EMF will be, that is 3.6 into 10 to the power minus 5. So power will be 3.6 into 10 to the power minus 5 whole square by R. R is how much? R was 6 milliohms. Right, so if you solve it, it will be 3.6 into 3.6 upon 6 into 10 to the power minus 4, right? So it will be 6 ones are 6.6 are, so it will be 2.16. So it will be 216 microwatts. So what they have given, 10 to the power minus 9 watts, na? Wait, so 10, yes, 6, 6 milli, oh sorry, I thought micro, that's a mistake there. So 6 milli, na? Milli means 3, okay? So this will be 7 minus 9, yes. So our answer will be 216. Clear, everybody? So hell of a good question. It took some time to solve, but worth it. Okay. Now the distance between object and its 3 times magnified image. So what they are saying, this is a convex mirror, this is object, image is 3 times magnified, this distance is u, this distance is v. Okay, so 3 times magnified. So magnification क्या होता है? V by u. So from here we will say that 3 is equals to v by u, so v is equals to 3u. Now they have also given us this distance is 20 centimeter. So magnitude wise v minus u is equals to 20 centimeter. 3u minus u is 20 centimeter. So 2u is 20, u is 10 centimeter, right? If u is 10 centimeter, then we will say, sir, 1 by v minus 1 by u is 1 by f. Now put the values along with the sign. 1 by minus 30 minus 1 by minus 10 is equals to 1 by f. On solving this, focal length will come out to be 15 centimeter. Okay, students? Very simple question. To identify, इसका तो formula याद रखो भाई. ये question बहुत common है. पता नहीं why it keeps coming. It's a very common question. It keeps coming multiple times, right? This angle theta maintains same. So we will say that here remember k is equals to 1 upon 1 minus rho L by rho naught. That means object density of liquid upon density of object. So in this case you will say, sir, it is 1 upon 1 minus 1 upon 1.5, right? So it will come out to be 3. So if you remember this formula, which I really tell my students all the time, so just remember this formula, because if you remember this formula, it saves you a whole lot of trouble of solving this, you know, that initially this is electrostatic force, this is mg, then afterwards it becomes f by k, and this becomes mg minus fb, right? Saves a whole lot of a trouble. Remember this formula. Okay, so oh god, very easy. R is equals to R naught into a to the power 1 by 3. So first is 64. Oh, mass number na. Acha. So 4.8 is equals to R into 64 to the power 1 by 3. 4 is equals to R into a to the power 1 by 3. You take the ratio. 1.2 is equals to 64 by a to the power 1 by 3. Right? So we can solve it, and a comes out to be, sorry, x comes out to be 27. Question is very easy. Here they have said that arrange them like this, right? 2m, 2m and 2m. So let's decide this is origin. So this coordinates will be 0, 4 and these coordinates will be 4, 0. Okay, now find out x coordinate. So x coordinate of center of mass will be what? m1 x1 plus m2 x2 plus m3 x3 upon m1 plus m2 plus m3. Yes or no? Just put the values now. Take this as m1. So m1 is 2m into 0. 0 plus, here also x coordinate is 0 plus 0 plus 2m into 4 upon how much? 6m. So it will be how much? 4 by 2 ones are 2 3s are. So it will be 4 by 3. 4 by 3 meters. This is x coordinate. Now if you look here carefully, here these two were at origin. These two had 0 x coordinate. Next time these two will have 0 y coordinate. So if you figure out, y coordinate will also come out to be similar, 4 by 3. So overall r will be 4 by 3 root 2. So this will be your answer 3. Got it? So the distance, position vector का distance जो आएगा ना, this will be 4 root 2 by 3. Let's see, a tuning fork resonates with a sonometer of wire of length 1 meter stretched with a tension of 6 Newton. Okay. So frequency का formula क्या होता है? n by 2l root over t by mu. Considering the fundamental state, they have not given anything. Length is also 1 root over tension t by mu. So mu is also constant. So you will say, sir, f1 by f2 is equals to root over t1 by t2. Cool. So f1 by f2 will be 6 by 54, 6 ones are 6 nines are 1 by 3, right? And they have given that 12 beats are heard. F2 minus F1 is 12. So I guess we can solve. The frequency of the tuning fork is F1, they need to find out. So F2 will be 3F1 minus F1 is equals to 12. So 2F1 is 12, F1 is equals to 6 Hertz. That will be the answer. Okay, students. So that's all from my side today. So I'll discuss the second shift also. Okay, so I hope you understand. Okay, if you feel that I was explaining a little fast, you can pause the video and understand things. I'm writing everything here. Practice with me. Okay, so those who are attempting for the second attempt or going for the second attempt in April, please solve these questions once again. These are really nice questions and will give you a good boost for the next preparation. Thank you. Stay with us. Thank you so much.